Spatial hearing, ITD, ILD, HRTF, horizontal plane localization, median plane localization, distance localization, audium, audible angle, directional band, BMLD, and so on. Some definitions before we start. Cue. What is a cue? Attribute or characteristic carried by an acoustic stimulus. Monaural cues. Cues that can be perceived with one ear. Binaural cues. Cues that can be perceived with 2 ears. Types of stimulus presentation. Monaural, only one ear perceives a sound signal. Diotic. Both ears receive an identical sound signal, and dichotic. Both ears receive a different sound signal. Visual versus auditory. Retina cells are sensitive to direction, very high spatial accuracy, only frontal area. Cochlea has no direct sensitivity to direction of sound. Spatial hearing is based on signal analysis in the brain or around localization. Yeah, cochlea is important. Spatial hearing based on signal analysis in the brain. Recap of the ear. Outer ear acoustical system, middle and inner ear with ossicles and cochlea, mechanical system, and then the auditory nerves are the so-called electric neural system, and it's from the membrane and through the auditory nerves in a complicated way for the brain to get the informations in form of electrical spikes. Head-related transfer function. We have a horizontal plane, we have a frontal plane, we have a median plane. Yes, frontal horizontal plane is just the earth, is a vandret, lodret, frontal plane lodret, and median plane is just cut through the head. You half the head from in front. Interoral differences. What's that? Different distance between source and left and right ear. Interoral in time difference. It is because of the different distance between right ear and left ear. But if the head shadow, interoral level difference. A little bit about interoral time difference. So if the source is near the right ear, then there's a longer distance for the waves to the left ear. It can be calculated. Yeah. Yes. Okay. And time in difference is difference in time in delta t ITD is a difference, the length difference divided by the sound speed. Yes. If you are okay, interoral time differences in milliseconds. If the source direction is 0, the sound is just in front of you, or should I say, in front of you, or you can also say back of you. There's no interoral time difference. If the source is if the source direction is 90 degrees, then you have a source in front of one ear, for instance, right ear, and then a big time difference between right ear and left ear. ITT physical and perceptual properties. There's a range between 0 is in the is 0 in the median plane. Okay, in the median plane, if the source is in the median plane, to 690 microseconds directly to the side. The just noticeable differences JNT vary with frequencies. They are most sensitive ITD between 700 to 1000 Hz. Okay, yes. Then there are some 700 to 7. Okay, most sensitive there. Yeah. Mhm. Yes, ITD uncertainty at high frequencies. Which signal arrived first? There's ambiguity for tones above 750 Hz when signal onset information isn't present. Because there can be some phase confusion. But or else you can say that ITD is more biggest when with low frequencies because of high wavelengths. High wavelengths means that there's a lot of diffraction. So then you are able to hear sounds of both ears. Physiology, ITD at high levels, high frequencies. At low frequency, it follows temporal fine structure representation. At high frequency, it's an envelope representation. Yeah. The transformation from mechanical vibration to electrical potential is limited at high frequencies. ITD summary. Difference in path lengths leads to difference in time of arrival. Okay, time, path lengths. Difference between 0 and 690 microseconds. Most sensitive at low frequencies. Yeah, okay. Then we have the interval level difference. Sound waves have to diffract around the head. Sound waves have to diffract around the head. Then there's a head shadow, reduced sound level at 1 year. Yeah. Reduced sound because of the head shadow, reduced sound level at 1 year. Especially when with high frequencies, they are not diffracted much. Then there is really a reduced sound level at 1 year. 1 year. When the frequencies are lower, wavelengths higher, there is more diffraction, and you can then the ILD is lower. Yeah. ILD physical properties. If you have a 5000 Hertz, very high frequency, the inter-or level difference is 0 at 0 degree because it's in front of you, but at 90 degrees, and the direction degrees is at 90 degrees, then there's a big auto level difference. So it's not as big at 300, 3000 and 1000 Hertz, and especially not for 200 Hertz. For 200 Hertz, even on at a 9 direction and at 90 degrees, there's no big interaural difference. Why? Because at so low, at very low frequencies, there's a big diffraction. Yeah. Loudspeakers producing tones, measurements with microphones in the channels. Okay. Ecological range. It's 0 in the medium plane to 20 decibels directly from one side at high frequencies. ILD just noticeable differences are approximately constant across frequency 1 to 2 dBs. Then we have ITD, ILD, and frequency is also called duplex theory. Yeah. Yes. Also interaural level differences, ILD. Yes. ILD available at all frequencies, most salient at high frequencies because of there's no diffraction. ITD is most salient about below 1500 Hz, but it can be detected at higher frequencies via signal envelope. Okay. Yes. Minimal audible angle. That is the smallest angle between two distinguishable sound sources in the horizontal plane. You have a first axis frequencies from 100 to 10,000 Hz, and you have the minimum audible angle at the second axis. If you have a 0 degrees azimuth, there's only so you are in front, then there's just a small minimum audible angle, not more than 3 degrees. If you have 30 degrees azimuth, then the audible angle is increased with higher frequencies. Yeah, from 1500 Hz or 2000 Hz, it's more than that from 0 degrees. Best accuracy below 1000 Hz and straight ahead. 1 to 2 degrees correspond to ITDs of approximate 10 to 20 microseconds. Yes. Summary: ITD and ILD. Horizontal plane localization using two main cues, ITD and ILD. Interaural time difference, ITD, that is a difference in arrival time at both ears, dominant Q at low frequencies less than 1500 Hz. Envelope ITD information at higher frequencies. Okay. Interaural level difference, ILD, difference in level at both ears. In level, yeah. ITD is the difference in arrival time, and ILD is difference in level at both ears. Dominant Q at high frequencies. Yes. Then because of less diffraction, ILDs are small at low frequencies because of the big diffraction. Big wavelengths, much diffraction. How do ITD and ILD cues compare between both loudspeakers? Same ITD and ILD. Okay, that's it. That was part 1. Thank you.